All right, thank you. So I think all of you are so looking forward to the activities in the afternoon. Okay, so I will talk fast. And where is my workshop 5 students? Workshop 5. Okay, yeah, you choose the right workshop. Okay, it will be very interesting. So let me show you something. Okay, about the science behind animation making. Okay, so I will talk very fast. Okay, so because I really want you to have more time to work on your activities and enjoy everything you have created. Okay, so let me start. So first of all, okay, for animation, so I show you some of the animation I obtained from the web. Okay, so we create animation for many reasons, not just because of the excitement, but as you can see, sometimes we do need animation in order to visualize things more clearly. Okay, if I tell you the atom is surrounding the nucleus and rotating clockwise or counterclockwise, or if I tell you the Earth is rotating from the west to the east, okay, you may somehow think that it's not very easy to understand the idea, right? But if I can create something moving and you can simply see it and understand it, okay, things becomes easier, okay? So we create animation for many reasons. First of all, for practical usage, to demonstrate our daily life experience or to share some of the experience to your friends, okay? So I would like to draw your attention to these animations. So first of all, for this one, okay. So would you think that it is a real animation or something happened in the real world? It can, okay, it can be, okay. So, but I think you have already know that it is a fast-forward animation, okay. You cannot see the snow accumulating in a seconds from the floor and all the way up to my shoulder, okay. That will be very terrible. But it is an animation with all those photos taken from the most recent snow in the North America, okay. So after putting lots of pictures all together and show it in within few seconds, you see something like that. Yeah. Okay, so this is one of the examples showing that how animation will demonstrating your daily life experience. And sometimes it gives you the convenience to visualize something which would take very long time to experience. Okay, and it looks funny. And I think the more funny thing is here. Okay, sometimes we can use animation to show some abstract idea or something even impossible to take place in the real world. By the way, how many of you would think that it is a real animation? Have you ever seen a chicken popping out an egg and have all the balls on the snooker tables going into the holes? Okay, how many of you would believe that it is taken from a real case? Yeah, good, okay. But of course, he's wrong, okay. Actually, if you know about the motion well, okay, if you really try to work it out, you could never create something like this. But it is just something created by the author. Okay, so they just take picture from time to time and moving the balls from a new position, and then put all the pictures together and give you some sort of illusion. Okay, and then you may you may wrongly perceive that it is the power of the eggs. Okay, colliding with the balls, and then all the balls will go into the holes, and then the chicken is a very powerful snooker player. Okay, but it is not a real thing. For the animation at the bottom, it may not be so clear, or maybe we will see more clearly with the lights off. So actually, it is a bird kicking out another bird and looping infinitely. Okay. So let's see if we can switch the light a little bit dimmer, okay? And again, it is not a real case, okay? You won't see a bird keep kicking out another bird and then they queue up again and looping infinitely, okay? No one's in natural environments could last that long, okay? They will get tired, they will be hungry, okay? And, or they will be caught by the other animals, okay? So, actually, we can use animation to do a lot of things that we cannot experience in our daily life. Okay, so what is the science behind those animation? Okay, so in order to make the animation looking so real or so move, you cannot take too few pictures. You have to take a lot of picture and put enough picture in 1 second in order to have a very smooth animation. So the phenomenon behind is called we are making use of the phenomenon called persistence of vision. The Chinese is called the 視覺暫留. Okay, so actually it is the after image lasting on our retina for some times after we see the image. So actually, when I look at you, okay, there are some photons, some light signals sending to my eyes, okay, and my retina is going to recognize this kind of optical signal. But when I shut my eyes, the signal won't die out immediately. It will last for a very, very tiny short time, even I shut down my eye or have the lights goes off. Okay, that's a very interesting features of our human eye. Okay, so because of these features, okay, let me ask you a question. How many frames per second in order to show a smooth animation? We can get this number, we can get a roughly correct number from this typical number here, okay? Because the optical signal on our retina could, you may say, could memorize the image for about 1/25, okay, second, okay? That means we need roughly about 25 pictures in a second in order to treat our eye and tell it that it is a smooth image, okay, or a smooth animation. Actually, this thing taking place everywhere in our daily life. So, for example, for those white fluorescent lamp, okay, it is actually turning on and off 50 times in a second. But can we see the blinking? No, right? We cannot see it turning on and off because it is turning on and off so fast, so that our eyes cannot catch that up. Okay, so that's also a result of the persistence of vision. Okay, it is a very simple concept. Okay, so now you know more. Okay, I think all of you have already know about the names, okay, of the features in our eyes, and it is the retina collecting the light signal, and then the signals will go into the optical nerve. Okay, and this one is trying to show that within 1 second, actually there are so many pictures putting into a sequence in order to giving us a very smooth animation feeling. Okay, so I think for many of you have already learned this picture in your school, in your science class. Okay, in this picture you are told that the camera is working very similarly to our human eye. Okay, the lens corresponding to the lens and the diaphragm corresponding to the iris, and the film is just like the retina, which is used to collecting the light signal from the surrounding. And is it the end? Okay, I would say no. Okay, you may also keep asking, okay, after those collection of signals, where would they go? They will go to the nerve, okay, and then, okay, what is the what organ is going to process the optical signal collecting from the eye? Okay, the nerve at one end is connecting to our eye. At And then at the other end is connecting to our brain, okay? And then you may ask, what's happening in the brain, okay? And my answer is, I don't know. Or you can also ask your teacher in the secondary school, or you may also ask our student helper, and even ask our professor in Hong Kong U. I think for many of them will give you similar answer. We simply don't know what happened in the brain, how the brain handles those signals and telling us it is the image you can see. Okay, it is a very big and challenging question. If you are interested enough in what's happening in the brain, I would encourage you to search for the videos, the brain story from the web. It is created by BBC or Discovery, I forgot, okay? But it is very easy to search it from the YouTube, okay? And try to know about how our brains works in order to give rise to our sense, okay, for every organ, okay? You may also ask that, how can we hear, okay? We know that it is our ear to collect the signal, but how do our brain process those signals? Okay, that's the very, very big question. That's challenge a lot of the experts. Okay, even the professor in Hong Kong, you most often cannot answer this question. If you can answer that, you'll be my professor. Okay. So, next, I'm going to show you another very interesting small animation done by a group of scientists. Okay. You may heard about the IBM, okay? It is the company who creates a lot of computers, okay? But they do another very interesting thing. They create an animation by atom. It is called the smallest movie in the world ever, okay? So let me show you the boy and his atom. Oh, sorry. So let me ask you one more question. Do you think it is a very, very smooth animation? No, right? You see from pictures to picture, there is a little bit jumpy, right? So how would you solve that problem? What do we need? We definitely need more pictures in between, right? In order to make the pictures, make the animation looking smoother, right? So this one is not easy to create because they are manipulating very, very small atoms. So we know that atom is the fundamental elements that form everything in the world. Okay, so they are manipulating the very fundamental building blocks of the world and creating a movie. So that's not easy. And we are so sorry that we don't have the technique for you to create your own animation using atom. But we have something else, which is also very interesting enough. It is the Lego. Okay, I'm also a very expert Lego player for more than 30 years. Okay, I keep playing that until now. Okay, so For our workshop 5 students, it'll be your job, okay, to create your own Lego animation. So from this second on, you can think about what kind of interesting story you can come up with by building the Legos, and you'll be helped. Okay, you will have someone to help you to put your story into a real Lego animation. So here I'm giving you an example for one of the Lego animation I can find on the web, and I hope that it can inspire your idea as well.
Hey, let's go bowling. Okay. $10, please. Ha! I can do better. Not like that. Like this. Your turn. Did anyone see? Ah, my foot! Ah! I'm sorry for that. It's okay. Do they always suck that bad? Maybe. Ah! Hey. Same time next week? Of course, as always.
Yeah, so actually it is not easy to produce the Lego movie like that. Okay, as you know, in order to make a very, very smooth movie, you got to take a lot of picture, maybe 24 and 25 in a second to make it smooth. If you don't have if you don't have enough time, or you may make fewer pictures, and so that the movie will still look a little bit jumpy. Okay, and in order to produce about 3 minutes of animation, you can calculate the number of pictures you need to take. So it's not an easy job. But on the other hand, as you can see, you can create a lot of things that you find funny, and when it is visualized using Legos, it can be funnier. Okay, so I hope that you can enjoy the building of animation, and also for the rest of you, I wish that you can also enjoy all the other workshops. Okay, that's all of my talk. Thank you.